Last question. Last question is about kinetic model of matter. So I've written here all the possible options that you have. If the question asks you to describe motion of molecule, you have three types of motion: vibration, slide and roll, moving freely and randomly. So of course, if it is solid, vibrate about fixed position. By the way, all this term is fixed. You must give me all these keyword. If not, if you use your own word, I cannot give you full mark. But of course, I won't be so mean. If you say randomly moving, freely moving, I will give you the same. I will give you the full mark. Okay, as long as I see the word free, random, and move. Okay. If you want to talk about arrangement of molecules, there are only two types: orderly or disorderly. So if it is liquid, then of course it is not orderly. You can also use the word random. Okay. Describe motion, but this time round you want gaseous state, so obviously this one. Okay. Okay, for your part B is your temperature time graph. Be very careful. Down here the time is in minutes. So if they ask you in seconds or they give you the power, the time must be in second. So whenever I have graph, I tell myself I must check the unit because I wrong too many times already. Okay. So first you need to identify, of course, what is the starting state. So you need to my habit is always to consolidate all the information on the same diagram. So I know that this is solid at the beginning. And then of course this plateau, if I start with solid, then that means this must be melting. And then after that, after it melt, it will be liquid, right? So this particular point will be my first point of liquid. Then after that, at this point, it's all liquid. Then from liquid, I continue hitting it. Then this part must be boiling, right? Then after it boil, then from this part on, it will be gaseous state. For revision purpose, then melting, what is the state during melting? Well, it will be a mixture of S and L. It's a mixture of solid and liquid. Same thing for here, during boiling, it will be a mixture of liquid and gas. So the keyword is mixture. Okay, it is a mixture. Then after that, all the other value is given over here. So you have 65 boiling and you have minus 98 melting. So you see, just by reading the thing, I already got so many information. What is the state? I think we have already answered that, so I'm going to skip. By the way, if they ask you what is the state of B, the model answer, I must see mixture, solid, and this is N, liquid. And of course, you need to spell this out. You need to spell this solid and liquid. Okay, if you do something like this, I will mark you wrong. It is not or, it's not either or, it's a mixture of both. State the boiling point of the substance. We have already stated it, right? 65, right? Because it's a plateau. So all this plateau, basically it is an indicator for state change. So if you see that it goes flat, it means that it must be changing state. Or if not, it is reaching room temperature. So for example, if it hit until minus 110, right? Then of course it will plateau over here. But then this flat line doesn't mean that after it boils, it cannot change anymore. So this is when it reaches thermal equilibrium. So this thing is called thermal equilibrium. That means it is already same temperature. It means same temperature as surrounding. So it is just a more technical name of the object has already reached room temperature. Okay. So here it says, this one is a typical question. I think every year ScPhy always asks when heat is being supplied, why is it that the temperature remain constant in region B? So what happens is that whenever you are going through state change, the energy is actually channeled in very differently. So you need to give the standard answer that the heat supplied is converted to IPE, and is converted to IPE to do what? To break the bonds. the intermolecular bonds. Okay, so here you explain, you are accounting like where the energy goes. Then after that you need, so here you account for where the energy go. Next you must explain why the temperature is constant. So you have to say something like hence your internal kinetic energy is constant, because your internal energy is the energy that is responsible for temperature change. Okay, so this is basically the standard answer. You must provide all these three parts in order to get the 2 marks. Okay, so since you see that there are still space, right, you can put like therefore temperature is constant. Yeah, you'll be able to occupy the whole thing once you spell this out. Yeah, if you do not know what is IKE, right, please go and refer to my notes. Internal kinetic energy. Okay. Okay, for your part 4, now, so at the beginning the solid is being heated up, and now the solid is being left to cool. So it is cool from 110. So 110, it is already in the gaseous state, right? So like I said, I like to put all my things over here. Gaseous state. Then you see this flat line, right? Flat line is an indicator of state change. So gas, after it cool, of course, it will be condensation. And then after it condense, it become liquid. Then after that, 28. So although this flat line is very tempting for me to just say that it is freezing, but I need to check. So actually it melt at minus 98. So you need to know something, that is your melting point and your freezing point, right? They share the same temperature. Both of them will be minus 98. Yeah, similarly for here, right, if it boils at 65, right, you will see that it is also condensed at 65. Yeah, so boiling and condensation, same temperature. Melting and freezing, same temperature. So here you can see that actually this one is not, or I shouldn't point here. I should point here. So this 28, right, is not the melting or freezing point. Right, if it is not the melting and freezing point, then you may ask me, hey teacher, then how come it's flat? Because there is a third reason. If your temperature is flat, it means that it has reached room temperature, right? Correct or not? Yeah, that means the technical name is thermal equilibrium. So of course this part, you need to know that this part is flat because it reaches thermal equilibrium. In another word, it has reached room temperature. Okay, so let's see what the question asks. What is the state of substance in region S? You see, they're very tricky. They want to trick you to say that this is melting. Okay, but it is not melting, it is not freezing either, because you need to compare with the first diagram. So actually it is not melting or freezing, it is just still liquid, right? Because it's like you have Milo in, you have hot Milo, and then you leave it in the coffee shop, you leave it to cool. Will you get iced Milo? No, right? You will just get cooler Milo. So this one is still liquid state. Okay, and you need to explain why the temperature of the substance didn't change, right? Well, it didn't change because it has reached thermal equilibrium and it has reached room temperature. So in another word, when your object is at the same temperature as the surrounding, will there be heat loss or heat gain? No, right? So because there's no heat gain or heat loss, same temperature. Yeah, oh yeah, we have reached the end. So that is the end of the paper. Like I said, 2020 paper is a very easy paper. So next week we are going to have a mock exam, and then week 4 you are on your own, then you are good to go.